Hey, what's good in the hood? I'm your boy Dexter the Tutor, and this is another SAT math problem. I call this one Ridiculous Radicals. In this series of questions, we're going to determine once and for all what to do when we see that little division sign that looks like a check mark. It's called a radical, and what it represents is an exponent that's fractional. The exponent inside the box goes in the numerator, and the number outside the box, aka the index, goes in the denominator. A good rule of thumb is that the number inside will go on top, and the number outside will go on the bottom. We'll start first with the warm-up that reads, which expression is equivalent to the square root of x to the 165th, where x is greater than 0? Whenever they give you an inequality that involves 0, they're really just saying if it's positive or negative. Since x is greater than 0 here, we can just assume that it's positive. You also might notice that there isn't a number whenever we square root something because there's an understood 2 that's not written. It's very similar to how if there's a letter by itself, there's an understood coefficient of 1. It's also similar to when there's a log base and answer that match, that it equals 1 as well, but I haven't done a logarithmic equation on an SAT since 2014, so we can just go ahead and log out the logs. So if we're following this formula of the inside exponent going in the numerator and the outside index going in the denominator, we can see that answer choice B is our answer. Answer choice A has it inverted, answer choice C has 165 minus 2 for the exponent, and D has 165 times 2 for the exponent. Answer choices like this are designed for you to spin the wheel of random logic, do some stuff with the numbers in the problem, and take that random logic with you for the rest of the test, so you can bomb like Hiroshima. Let's move on to a more intricate question. In this question it reads, the expression 16x to the third times 3x to the 7th is equivalent to bx to the 10th, where b is a constant. What is the value of b? Once again, constant is just a term for value, so I'm going to disregard that. I'm going to take this time to make a distinction of when you add exponents versus when you multiply them. When you multiply two common bases together, the result will be that same base with the sum of those exponents. For example, if you had x squared times x to the third, you'll get x to the fifth. This is because x squared represents x being multiplied twice in progression, and x to the third is x being multiplied by itself 3 times, giving you 5 x's that are sequentially multiplied. However, if you have a single base with an exponent to the exponent, you're going to multiply those exponents together, and the new exponent is going to be its product. So x squared to the third power is going to equal x to the 6th. I want you to pay very close attention to how many bases there are when you add versus how many bases there are when you multiply them. In this question, there are 2 common bases of x, so we're going to add them. So we set up the problem, 16x to the third times 3x to the 7th is equal to bx to the 10th. The product of the coefficients, 16 times 3 is 48. And the product of x to the third times x to the 7th is going to equal the sum of the exponents at x to the 10th. And all of this equals bx to the 10th. We can see that the answer is 48 just by looking at it transitively on both sides, or we can solve it algebraically by dividing both sides by x to the 10th and getting b equals 48 that way. Now let's take a look at a question that you'll see in the later parts of the test where they try to poke and prod you like some cattle. Moo moo. In this expression, the cube root of 119n is being multiplied by 119n root 6 to the 5th power. The question reads, for what value of x is the given expression equivalent to 119 to the 15x power, where n is greater than 1. Once again, what they're saying is n is greater than 1, meaning that it's not going to be less than 0, and we won't create a complex number. In other words, just disregard it for this question. I'm going to convert each individual factor into a fractional exponent. The cube root of 119n converts into 119n to the 1/3 power. 119n root 6 to the 5th power will follow what we said earlier, with the exponent becoming the numerator and the index becoming the denominator. And we cap it all off to make it equal 119n to the 15x power. Once again, we're here with 2 like bases, so we're going to add the exponents together. And now we need to have them have the same denominator before we add them. Yes, this is a rudimentary skill from elementary school, so they're really just trying to test your endurance on this part. The least common multiple between 3 and 6 is simply 6, so I'm going to scale 1/3 by 2, giving me 2/6. Finally, we add the numerators with the denominators staying the same. When we're in this position on the test, with the single common base on both sides of an equation, we can cross them out and make the exponents equal to each other. And the final stroke is to divide both sides by 15, giving me 7/90 as my answer. A quick reference trick is if you divide a fraction by a whole number, you simply distribute that whole number into the denominator, leaving the numerator untouched. Now let's do one last one that's the hardest of the hard, and I promise you I'm done after this. Scout's honor. The question reads, p to the 5th root 7 is equal to t to the 3/4 power. In the given equation, p is greater than 1 and t is greater than 1. If t is equal to p to the 3n plus 2 power, where n is a constant, what is the value of n? First, let's take out the unnecessaries and convert everything into a fractional exponent. This looks like a dilly of a pickle because there's so many different ways that we can approach this. In this display, I'm going to solve for t in the first equation and then substitute it into the second. But how do I solve for t when I have a fractional exponent? In order to get rid of a fractional exponent to isolate a variable, we simply put both sides to the reciprocal power. Currently, t is to the 3/4 power, so I'm going to put both sides to the 4/3 power. Remember that we multiply exponent to exponent, so t to the 3/4 power to the 4/3 power is going to end up equaling 1, isolating t because anything to the first power is itself. We don't need a common denominator when we're multiplying fractions, so we just go straight across the numerators and denominators. 5 times 4 is 20, and 7 times 3 is 21. I successfully isolated t, so now I can substitute their values, making p to the 20/21 power equal to p to the 3n plus 2 power. And just like we did before, when we have common bases on both sides, boom, they're gone, and I'm almost there at the finish line. The next step is to subtract 2 from both sides. I'm going to skip a scaling step by subtracting 42/21 from the left, giving me a -22/21. I finish it off by dividing both sides by 3, which distributes into the denominator for a final answer of a -22 divided by 63. Oh my god, that's a lot. There's not enough dad jokes in the world to make that interesting. But keep on grinding and scrapping and fighting for every single point, so we can finally show this test once and for all that they are not as strong and we are not as weak. If you find this video helpful, please like, share, and subscribe, and always remember, in order to reach someone's mind, you must first care about their heart. Because if you don't care about their heart, you got no business messing with their mind. 1.